In this video, we will be understanding a concept called standard form. Now, normally in mathematics, we can work with numbers which are either too big or too small to write down on paper. Numbers like these often take up too much space and time, causing us to become very confused and make mistakes when operating on them. To solve this, mathematicians created a standard form of writing which simplifies numbers. In standard form, numbers are written between 1 and 10 multiplied by a power of 10. For example, the number 10 is simply just 1 times 10. The number 100 is 1 times 10 times 10, which is 1 times 10 squared. The number 22, using that same logic, is 2.2 times 10, and 220 is 2.2 times 10 squared. This shows us that every number can be written in the form a multiplied by 10 to the power of n, where a is any number between 1 and 10, and n is any integer. In addition, this rule also applies for small decimals. For example, 0.1 as a fraction would be 1 divided by 10, which would be 10 to the power of -1. Therefore, in standard form, it would be 1 times 10 to the power of -1. 0.0005 would be 5 times 10 to the power of -4. In both large and small numbers, we are simply just counting the number of places moved from the significant number. Now, when we are asked to operate on standard form numbers, it is not different from the ideas we previously understood. First, if we are asked to multiply or divide, we just use the ideas we learnt with indices. For example, if we are asked to multiply 7 times 10 to the power of 3 and 4 times 10 to the power of 4, we would just match similar expressions together and solve them individually. In this case, 7 times 4 would be 28, while 10 to the 3 times 10 to the 4 would be 10 to the 7, as multiplied powers are added together if the base is the same. Therefore, our answer would be 28 times 10 to the power of 7. However, as we said before, the first number needs to be between 1 and 10, so we must divide that number by 10 and place that 10 into the power, making our final answer 2.8 times 10 to the power of 8. Another example would be 3 times 10 to the 8 divided by 5 times 10 to the 3. Again, we must group similar expressions together. 3 divided by 5 would be 0.6, and 10 to the 8 divided by 10 to the 3 would be 10 to the 5, as divided indices are subtracted if the base is the same. Therefore, our answer will be 0.6 times 10 to the 5. Again, we would need to push the decimal to make the first number between 1 and 10, so the answer will be 6 times 10 to the power of 4. Note that we decrease the power in this case as we are multiplying the first number by 10 instead of dividing it. In terms of addition and subtraction of standard form, it's much safer to first convert the numbers back to their ordinary state before operating on them. For example, if we wanted to add 7.2 times 10 to the 5 into 2.5 times 10 to the 4, it would be best to convert them to ordinary form, which would be 720,000 plus 25,000. Once added, the final answer would be 745,000, which when converted to standard form would be 7.45 times 10 to the 5.